Hello students, welcome to UNOYA. My name is Rizwan. I hope you all are doing well. So here in this video, we will begin the discussion of chapter 3 of class 10 NCERT mathematics textbook, that is linear equations in two variables. Okay. In the previous videos, we discussed about first two chapters. Okay. So let's continue our journey through the NCERT class 10 mathematics textbook. So here we will begin the third chapter, pair of linear equations in two variables. Okay, pair of linear equations in two variables. You can see here. Yes, this is our chapter 3. Okay, pair of linear equations in two variables. Okay, so here you can see this name contains many terms, okay, or many concepts are hidden in this heading. Okay, it is talking about pair, it's talking about linear equations, okay, equations and linear equations, okay, and also variables, two variables. Okay, many such things are there. Okay, so let's discuss each one. First one, let's begin with equation. Okay, what is mean by an equation? Equation is a statement. Okay, equation is a statement which says that the values of two mathematical expressions are equal. Okay, if you have anything like that, if you have two mathematical expressions, and if that two expressions are connected by one equal to symbol, which means the meaning of that is nothing but the values of those two expressions are equal. Okay, so that is an equation. For example, 2x plus y equal to 17, that is an equation. Or x square equal to 14, that is another equation. Okay, so x square is an expression, 14 is another expression. So x square equal to 14 means the value of x square and the value of 14 are equal. So it's connecting both mathematical, both of these expressions. Okay, or it is saying that the values of these two expressions are equal. Okay, so that is an equation. Okay, now what is mean by linear equations? Linear equation means the equation in which the exponent, the highest exponent of the variable is 1. Okay, such equations are known as linear equations. Okay, I can show you examples. Yes. For example, 3x plus 7 equal to 15. Okay, 3x plus 7 equal to 15. Okay, here x is the variable, right? X is the variable. Okay, x is the variable. And what is the exponent of x? Exponent of x is only 1. Okay, it is simply x, which means its exponent is 1. X simply means x raised to 1. Okay, so such equations, the equations in which the exponent of the variable, okay, or we can say that the degree, okay, the degree of that equation is 1. Okay, such equations are known as linear equation. Okay, so this is linear. Okay, this is a linear equation. Okay, now let's take another example. 3x square plus 7 equal to 15. Suppose this is our equation. Is this linear? No, this is not linear. Okay, this is not linear. Why is it so? Why this is not a linear equation? Because look at the exponent here. It is 2. It is x raised to 2. Okay, it is x raised to 2. Okay, so this is not a linear equation. Okay, we want x raised to 1 only. Okay, so such equations are known as linear equations. Okay, so this is linear and this is not a linear equation. Okay, similarly you can see with y also. For example, you have y plus 7 equal to 10. Okay, y plus 7 equal to 10. This is simply y, right? This is simply y. Y means y raised to 1. There the exponent of y is 1 or the power is 1. Okay, so this equation is also linear. Okay, this is linear. Okay, this is linear. On the other hand, if you have the equation y square plus 7 equal to 10 or y square plus 7 equal to 15. Okay, any number you can take. Okay, anyway, this contains y square or y raised to 2. Okay, so because of that 2, this is not linear. Okay, this is, sorry, this is not linear. Okay, not, this equation is not linear. Okay, or if you have y cube or y raised to 4, suppose you have, or x raised to 3, x raised to 4, suppose you have x raised to 3 plus y square equal to 20. Okay, x raised to 3 plus y square equal to 20. Is this a linear equation? No. Here you have x raised to 3, it's not x raised to 1. Here you have y raised to 2, it's not y raised to 1. Okay, the power, the exponents are higher, it's greater than 1. Okay, so this is also not linear. Okay, okay, so in the linear equations you will always find the exponent of the variable equal to 1. Okay, so such equations are known as linear equations. Okay, now let's come back to our name again. Yeah, we discussed about equation, we discussed about linear equations. Okay, then linear equations in two variables. Okay, after that we will move to the pair. Okay, now let's discuss linear equations in two variables. Okay, linear equations in two variables. Okay, for that, let me open it. Yes, so let me take you one equation. 5x plus 7 equal to 19. Okay, 5x plus 7 equal to 19. Okay, so here x is the variable, right? X is the variable. Okay, that is a letter from English alphabet, not a number, so it's a variable. Okay, so here how many variables are there? Only one variable, right? Here only x is the variable. That is the only variable. Okay, so this equation contains only one variable. Okay, but look at the chapter name. The chapter name is talking about equations in two variables. Okay, in two variables. So these type of equations are not the topic of our today's discussion, because here we have only one variable. Okay, but here but in this chapter they're talking about two variables, linear equations in two variables. This is only one variable. Okay, now yes, can you tell me one example for equations in two variables? Yes, you have to take one more variable. Okay, for example, 6x plus 7y equal to 8. What is the peculiarity of this equation? Here x is a variable, y is also a variable. Okay, so how many variables? X, y, two variables. Okay, so this is an example for linear equation in two variables. Okay, x and y are the variables. Okay, not necessarily x and y. You can take any other letters also. Okay, other variables are also possible. For example, y and z. You can take, for example, 4y plus 8z equal to 12. This is another example. Y is a variable. Z is also a variable. Okay, so in these two equations, you can see how many variables? Two variables. Okay, two variables. Okay, so all these equations are linear equations in two variables. Okay, in this equation you have only one variable. It's a linear equation but only one variable. Okay, but here both of these are linear equation as well as equation with two variables. Okay, so yes, now again let's move back to the name. Yes, we discussed about linear equations in two variables. Now take the last point, pair of linear equations. Okay, what is mean by pair? In pair you can see two, right? If anything is in pair, then you can find two of them. Okay, yes, so pair of linear equations in two variable means two linear equations in two variables. Okay, that means linear equations in two variable coming together. That is a pair of linear equations in two variables. Okay, for example, if you take the here also you have an example. If you take these two equations together, okay, if you are taking these two equations together, this is an example for pair of linear equations in two variables. Okay, because both are linear equations, both are having two variables. Okay, and they are two in number. There are two equations. Okay, so this is a pair of linear equations in two variables. Okay, so in this chapter we are talking about these type of equations. Okay, if you want I can give you one more example. For example, 10x plus 4y equal to 18. This is a linear equation in two variable. We want pair, so we want one more. We need to pair this equation. So that is, let me take another example. 9x plus 6y equal to 20. This is another linear equation in two variable. Okay, so total how many linear equations? Two. In this box you can see two linear equations in two variables. Okay, there are two variables. Okay, so x and y. Okay, both are x and y. Okay, so here we have one problem. Both are linear equations in two variables, but here the variables are different. Okay, here is x and y, here is y and z. Okay, here is x and y and z. Okay, so exactly in this chapter we are dealing with these type of equation. Okay, both of them are linear equations in two variable and the variables are also equal, xy. Okay, so in this chapter we are dealing with these type of equations. Here both of them are linear equations in two variable, but the variables are different here actually. Here is x and y. Okay, but here it's y and z. That is the problem. Okay, but here you can see exactly what we need in this chapter. So in this chapter we are dealing with these type of equations. Okay, so let's begin our discussion. So you can see introduction, you can see many real life examples where we can make use of pair of linear equations in two variables. Okay, so I will come to that. You can see some examples here. Okay, y equal to 1 by 2x. X and y are the variables. Okay, so both of them are with exponent 1. So that is a linear equation in two variable. This is another linear equation, two variable. X and y are the variables, two variables. X raised to 1, y raised to 1, power is 1, exponent is 1. So that is another linear equation in two variables. Okay, so if you consider both, this is a pair of linear equation in two variables. Okay, yeah. Now we have some methods to solve these equations. Okay, if you have a pair of linear equations in two variables, we have some methods to solve that. Solving the equation means finding the values of x and y, or finding the values of variables. If you have x and y as variables in an equation, solving that equation means finding the value of x and y. Okay, finding the value of x and y. Okay, and we have many methods for that. Okay, many methods. Okay, as a first method in this chapter, we will discuss graphical method of solution of a pair of linear equation. That means we can make use of graph. Okay, we can make use of graph to solve pair of linear equations in two variables. Okay, so let's see how can we make use of graph to solve. Okay, before coming to that, you should know some terms. That is nothing but inconsistent pairs and consistent pair of linear equations. Okay, what is mean by inconsistent and consistent? You can see the word inconsistent and also consistent. Okay, what is the meaning of this? You can read here. Okay, a pair of linear equations which has no solution is called inconsistent pair of linear equations. Okay, and a pair of equations in two variables which has a solution, or which has at least one solution, is called a consistent pair of linear equations. Okay, so you should remember this: consistent and inconsistent. If you have two equations, okay, if you have a pair of linear equations in two variables, it is known as inconsistent if you don't have any solution for that. Even after applying the methods of solving, if you are not able to find any solution for that, or no solution exists for that, in that case we can say that it's the pair of linear equation is inconsistent. Similarly, if the opposite of that, if a pair of linear equation has one solution or at least one solution, then we can say that it's consistent. Okay, so you should know these things. Now let's move to the other concept, that is yes. Okay, so here you can read. Okay, we can now summarize the behavior of lines representing a pair of linear equations in two variable and the existence of solutions as follows. Okay, I told you already that this is a method of solving linear equations graphically. That means we will draw graph, we will draw x-axis and y-axis, and we will draw straight lines as graphs of these equations. Okay, and with the help of that lines, we can find the solution of that pair. Now, if you are checking for that solutions through graphical method, there are three main possibilities. Suppose you are solving a pair of linear equations graphically. Suppose you are going to find the solution of a pair of linear equations by drawing their graph. Then there are three possibilities. Okay, three main possibilities. Okay, you can see these three possibilities here. Okay, these three possibilities. Okay, I will explain each one in detail. First one, the lines may intersect in a single point. In this case, the pair of linear equation has a unique solution, or that it's a consistent pair of linear equations. Consistent we already explained. Consistent means at least one solution. So here, what is the situation? The line may intersect in a single point. This is one case. I told you that we have three possibilities. We have three cases. This is the first possibility. What is the first possibility? The line may intersect at a single point, at one point. If the line is intersecting at one point, in this case, the pair of linear equation has a unique solution, or one solution. That point of contact is the solution. Okay, anyway, there is a solution, right? So at least one solution is there, so it's consistent. We explained about consistent. If at least one solution is consistent, so this is one possibility. I hope it's clear for you. Now let's move to second one. The lines may be parallel. This is the second case. In the first case, we discussed about line intersecting like this. Okay, but in the second case, the lines are parallel. We know that parallel lines never intersect. It will be like this. Parallel lines never intersect. Okay, so the lines may be parallel. In this case, the equation have no solutions. Solution means the intersecting, but the lines has to intersect to have a solution. But here you can see the lines are parallel. This is the second possibility. If you are trying to draw graph, if you are trying to solve equation graphically, this is a possibility. This situation may arise in which the lines are parallel. In such case, you cannot find any point of intersection for the lines. The lines never intersect. Parallel lines never intersect. So we can say that no solutions. If they are not intersecting, no solutions for that. Okay. So in this case, the equation have no solution. Or we can say that it's inconsistent. That is the meaning of inconsistent. Okay, we discussed a few minutes ago. Inconsistent means the pair of linear equations in which no solution. Okay, if they have no solutions, they are inconsistent. Okay. Now let's move to third possibility. The lines may be coincident. Okay, lines may be in this case, the equations have infinitely many solutions. Okay, or they're dependent or consistent pair of equations. Okay, that means this is the third possibility. The lines may be coincident. The line may be both of them lines are together. Okay, the line is exactly one line above the other. Okay, exactly the first line completely coincide in the second line, or the second line completely coincide in the first line. Lines are together. Okay, in the first case, it's intersecting at one point. Second case, it's like this parallel. Third case, both of them are together, or both of them are coming, going like a single line. That means at every point, they are intersecting. If they are intersecting at every point, how many solutions? Infinitely many solutions. Every point is a solution. So it has, you can see the equations have infinitely many solutions. Okay, this is the third possibility. And that is also consistent. Okay, it's a consistent. Or we can say it's dependent also. Consistent means at least one solution. If it is having infinitely many solutions, definitely at least one solution you will find. So it's consistent. So these two are consistent, first and third case, because it has at least one solution. And second case, it's parallel, it has no solutions. So it's inconsistent. Okay, so these three are the possibilities. Okay. Now you can see the examples here. Okay, consider the following three pair of equations: x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. Here the lines intersect. This is the first case. Okay, they are intersecting at one point. You can find if you draw the graph. I will explain how to draw the graph later. So now just understand that it is an example for intersecting lines, or the pair of linear equations with exactly one solution, a unique solution. Okay, you can see this after drawing the graph, or without drawing the graph, by looking at the coefficients itself, you can see. That also I will explain later. First, understand that this is an example. Okay, now second one, 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. Here the lines coincide. That means one line is exactly on the other line. Okay, so this is an example for infinitely many solutions, coinciding lines. This also you can see if you draw graph, both of them lines are moving like a single line. They are converging to form a single line. You can see by drawing graph, or you can see by looking at by analyzing the coefficient. There is an equation to find that. I will explain later. Anyway, this is an example for coinciding lines. Next one is parallel. That means without solution, inconsistent. This is an example for that. X plus 2y minus 4 equal to 0, 2x plus 4y minus 12 equal to 0. This is an example for parallel lines. That also you can see. Okay, I will explain later. Okay, now let's discuss how can we find, even without drawing graph. Drawing graph I will explain later, but even without drawing graph, we can understand whether a pair of linear equation is intersecting lines or coincident lines or parallel lines by just looking at the coefficients. I will explain with this example. Okay, I will explain. Okay, so here look at the first pair of linear equations. X minus 2y equal to 0. Okay, and 3x plus 4y minus 20 equal to 0. This is a pair of linear equations in two variables, right? Okay. Now let's analyze the coefficients. What are the coefficients here? Or what is mean by a coefficient? Coefficient means the numbers that you can see with variables, right? Or the last constant. These are the coefficients. For example, here x, you can see x. Simply x means it's 1x. 1x. So the coefficient of x is 1. Okay, so we can take this one as a1. A1 A means it's a coefficient of x. A1 means this is the first equation. We will take this equation as first equation and this equation is second equation. So the number 1 for this equation, number 2 for this equation. That number you can change. Okay. So here I'm taking, or here we are taking this equation as equation number 1 and this equation is equation number 2. So all the coefficients will be like A1, B1, C1 for this equation, because that is the first equation. And here the coefficients will be A2, B2, and C2. Now what about A? A is the coefficient of x. So if it is in the first equation, coefficient of x means A1. What about B? B means coefficient of y. If it is first equation, then it becomes B1. Similarly, C. Here you cannot find C, it's 0 here. Okay, here it's 0. Here you can find the last number. That number is C. This is for second equation. Then it's C2. If the C is for first equation, then it is C1. Okay, so here the coefficient of x is 1. So A1 is 1. Okay, similarly here the coefficient of y. What is coefficient of y? -2. Okay, you can see -2 with y. So the coefficient of y is -2. That means B1. Coefficient of y means B. Since this is the first equation, it's B1. So B1 is what? -2. Similarly, here we have no C. You cannot find any C, which means C equal to 0. C equal to 0 means here C1 equal to 0, because this is the first equation. C of the first equation is 0, which means C1 equal to 0. Okay. Similarly, we can find A2, B2, and C2. Coefficient of x of second equation, that is A2. Here it's 3, so A2 is 3. Okay. Now coefficient of y in second equation, that is 4. Okay, that is B2. B2 is 4. Similarly, the last constant, it's -20. It's C. Since this is the second equation, it's C2. So C2 is -20. Okay. So A1 is 1, B1 is -2, C1 is 0, and A2 is 3, B2 is 4, and C2 is -20. Okay. Now let's take the ratios A1 by A2, B1 by B2, and C1 by C2. Okay. A1 by A2 is 1 by 3. A1 is 1, A2 is 3. So A1 by A2 means 1 by 3. Similarly, B1 by B2 means -2 by 4. B1 is -2, B2 is 4. So B1 by B2 means -2 by 4. Similarly, C1 is 0, C2 is -20. So C1 by C2 means 0 by -20. Okay, yeah. So you can see all the ratios, A1 by A2, B1 by B2, and C1 by C2. Okay, now compare the ratios. Here in this equations, in this pair of linear equations, you can see that A1 by A2 and B1 by B2 are not equal, right? A1 by B2 is 1 by, A1 by A2 is 1 by 3. B1 by B2 is -2 by 4. Are they equal? No, they are different. 1 by 3 is different from -2 by 4. So here we can say that A1 by A2 and B1 by B2 are not equal. They are not equal. Okay. A1 by A2 is not equal to B1 by B2. In such case, they are intersecting lines. That's why I told you in the beginning. This is the method of understanding intersecting lines without drawing graph. By drawing graph, definitely you can find, because the graph will intersect at a point. Okay, then in that case, you can find that they are intersecting. But without drawing graph also you can find. That's why I told you a few minutes ago. By this equation, find A1, A2, B1, B2, C1, C2. Look A1 by A2 and B1 by B2. If A1 by A2 is not equal to B1 by B2, then it's intersecting lines. This is the condition for intersecting line. This A1 by A2 should not be equal to B1 by B2. And the peculiarity is exactly one solution. If it's intersecting line, it's exactly one. So that point of intersection is solution. That I already explained. Okay, so this is the condition for intersecting line. If this is happening, then it's an intersecting line. Okay, now let's move to second one. You can see another pair of linear equations. 2x plus 3y minus 9 equal to 0. 4x plus 6y minus 18 equal to 0. If you take A1 by A1 is 2, B1 is 3, and C1 is -9. Similarly, A2 is 4, B2 is 6, and C2 is -18. You can see, take the ratio A1 by A2, B1 by B2, C1 by B2, C1 by C2. All you can take. A1 by A2 is 2 by 4, B1 by B2 is 3 by 6, and C1 by C2 is -9 by -18. But all these are equal, right? 2 by 4, 2 is half of 4. 3 by 6, 3 is half of 6. -9 by -18, -9 is half of -18. or it becomes 9 by 18. These two minus will cancel. It's 9 by 18. All are 1 by 2, right? All are half. All can be simplified to 1 by 2. You studied about equivalent fraction, right? 2 by 4 is 1 by 2. 3 by 6 is also 1 by 2. 9 by 18 is also 1 by 2. So all are equal. All are 1 by 2. So we can say A1 by A2 equal to B1 by B2 equal to C1 by C2. All are equal. This is the conditions for coincident lines or infinitely many solution. I told you this case also, right? If two lines are exactly on the other line, if they are they have converged to form a single line, of both of those lines are together, this is the coincident line, and this is the condition. Even without drawing graph, you can check whether they are coincident lines or not, or whether they have infinitely many solutions or not. You can check with this equation. A1 by A2 equal to B1 by B2 equal to C1 by C2. Okay. Now let's move to the third one. You have another pair of linear equation here. You can find A, B, C, sorry, A1, B1, C1, A2, B2, C2, all you can find by the same method that we applied. In the same way, you can find A1 by A2, B1 by B2, C1 by C2, all you can see here. Or you can find, okay, A1 by A2 is 1 by 2, B1 by B2 is 2 by 4, and C1 by C2 is minus 4 by minus 2. You can apply the same method. And you can compare the ratio. What about A1 by A2? A1 by A2 is 1 by 2. And what is B1 by B2? That is 2 by 4. Are they equal? Yes, 1 by 2 and 2 by 4 are equal. Both are half. Both are equivalent fractions. Okay, so we can write A1 by A2 is equal to B1 by B2. They are equal. They are equal. Now what about C1 by C2? That is different. It's minus 4 by minus 12. That is 4 by 12. 4 by 12 is 1 by 3. Its equivalent fraction in simplest form is 1 by 3. It's different from 1 by 2, and it's different from 2 by 4. So not equal to C1 by C2. A1 by A2 and B1 by B2 are equal. 1 by 2 and 2 by 4 are equal. That you can see here. But that is not equal to C1 by C. That is different. This is the condition for parallel lines. If this equation is satisfying, A1 by A2 is equal to B1 by B2, that is not equal to C1 by B2, then those lines are parallel lines. Okay. So these are the conditions. Okay. By analyzing A1, A2, A1, A2, B1, B2, and C1, C2, or A1 by A2, B1 by B2, C1 by C2, and check for these conditions, you can find whether it's an intersecting lines or it's a coincident lines or parallel lines. Okay. So I hope all the topics discussed till now are clear for you. Yes. So that's all about our today's video. We will discuss the remaining topics in the next video. Okay. In the next video, we will discuss about drawing graph, how to draw graph. Okay. And how to solve based on graph. Okay. How to solve equations based on graph. Okay. And also we will discuss to find inconsistent and consistent. We explain how to find, we will solve some questions based on that. Okay, we will see some examples for them. By A1, A2, B1, B2, C1, C2. By look at all these coefficients, how can we find whether it's a consistent equation or inconsistent, or whether a unique solution, intersecting lines, coincident lines, or parallel lines, or in unique solution, infinitely many solution, no solution. All these things we have explained how to find by A1, A2, B1, B2, C1, C2 in this video. But in the next video, we will solve some problems based on that in the upcoming videos, in the remaining videos of this topic. Okay. So thank you so much for watching. See you next time. Take care. Bye-bye.